These are some revision questions for Secondary 2 Maths. Let's look at 1a. This is a multi-term expression. So in order to factorize them, we try to look at 2 terms by 2 terms. Now the first 2 terms, we are looking for common factors. First of all, we notice that 8 and 4 have a common factor of 4, as well as x. Since this is x squared, this is x, so we can just take out 4x. So this will leave behind a 2x. And the second term will leave behind a 1. So following the sign minus, so I have a 2x minus 1. Now for the next 2 terms, there's a common factor of just y. So I'll just take out a y. But just following the sign, negative sign, so I have to just put a negative sign here. I can put a 2x here. So the fourth term here to check, I have to ensure that I will get back a plus sign. So this will account for the minus sign inside. So this will be just 1. And the last 2 terms can simply just return in bracket. Now there are 3 terms, and they have all the same common factor, which is 2x minus 1. So factorizing completely, I will get 4x minus y plus 1. And this will be the fully factorized form. For part B, we notice that the first 2 terms are in perfect squares. So we have to express them in perfect squares. 4x squared for the first term. The second term will just simply be 1y, which is just y squared. Now followed by the last 2 terms. So I'll simply just take out a minus sign first, followed by a bracket to indicate that I'm following the laws. Now the fourth term is correct because minus and plus will give me back minus y. Now the first 2 terms will be factorized using the identity, which is a squared minus b squared, which gives us a plus b times a minus b. So in full form, it will be 4x minus y, 4x plus y. Now not forgetting the last term there, minus bracket 4x plus y. Now similarly to part A, we notice that both terms have common factor 4x plus y. So factorizing out 4x plus y, I will have the other factor 4x minus y. Followed by a minus 1. And this will be completely factorized. For question 2, we have to express both answers in algebraic fractions. So for fractions with different denominators, we have to find a lowest common multiple to represent the denominator. So in other words, we are trying to combine both fractions into one. First of all, we look at the first term. Its denominator is in square form in a quadratic expression, so we try to factorize it. Now notice that both terms are also perfect squares, so we'll change this into a perfect squares. so that we can see it's actually 3x square minus 1 square. We will try to leave the other term first, because the other fraction's denominator is in a linear form. So the first term, as per the other question, we factorize it using the identity. It would give us 3x plus 1, 3x minus 1. Writing the second term, we can actually at the same time complete the second term as per the first term by comparing the factors. Now if we combine them into a single fraction, the denominator must have the common factors. So in lowest common multiple, it will be 3x plus 1 times 3x minus 1. So this factor is missing out a 3x minus 1. So multiplying this to the denominator, I have to do the same for the numerator. And that simplifies everything into the same denominator, 3x plus 1, 3x minus 1. And the numerator will simply simplify to 1 plus 4 times 3x minus 1. Which further simplifies to 12x minus 3 over 3x plus 1 times 3x minus 1 In part B, it is very similar to this step. Now notice that the second fraction has a denominator of 2x minus 1 square. So in other words, I can rewrite the second fraction this way. So comparing, I notice that the common denominator is supposed to be 2x minus 1 square, which means it has two factors of this 2x minus 1. So similarly, if I multiply the denominator by 2x minus 1, I should do the same with the numerator. So it just be 2x minus 1. Well, the other side just remain the same first. And now the common denominator will be 2x minus 1 square. Simplifying the numerator by combining both terms, and that will simply give me 2x over 2x minus 1 square. Now this question, we have to derive the formula for volume of sphere and the volume of a cone. So volume of a sphere, 3D sphere with a radius of r, and its volume will be given by this formula, 4/3 pi r cubed. Similarly for the cone, with a base radius r, and the volume of the cone will simply be 1/3 pi r square height. The height will be the vertical height from the top to the center of the base. Now question given that the diameter of the sphere is 12 cm. We can easily find the radius. So the radius of sphere will be 6 cm. So in terms of pi, let's try to write out the volume of the sphere. Four-third pi, or we can substitute 6 cubed. And living in terms of pi, that will give us 288 pi. Now we can find the base radius of the cone next. Okay, given that the base diameter is 9 cm, so it will give me a base radius of 4.5 cm, which is 9/2. So similarly, using the formula for the volume of the cone, one-third pi radius is the base radius 4.5 square times the height, which is unknown, so we will just label h as the height. Now given that the volumes of the sphere and the cone are equal, okay, so we can simply use both formula for the volume and equate into an equation. Equals to the volume of cone, so 288 pi will be equals to 1/3 pi 4.5 square times h. Now notice that on both sides of the equation, pi is a common factor, so we can simply just cancel it out. And that, bringing over all the other terms, it will necessarily leave us h as the subject. On the other side, we will have 288 over 1/3 times 4.5 square. Now this gives us an exact number, which is 42 and 2/3 cm for the height. Depending on the answer, if it's in 3SF, you have to give it in 42.7, and always write down the degree of accuracy and units.